Good day, sir. Our topic is all about maritime navigation. We are the Group 10 and our member is Decadet Sumabal Chris Ian, Decadet Villanueva Marshals, Decadet Yik Yik John Paul, and Decadet Zespa Jason. The learning outcome is at the end of the session, the students shall be able to comprehend the history of maritime navigation radar and determine why radar is such a valuable tool to recognize the ship's parameter. New technologies of radar available to merchant shipping with the end of hostilities in 1945. A radar on merchant ship was initially installed for commercial purposes on ferries to maintain better schedule in fog and large fishing vessels. With improving technology and after some time, the use of radar for safety purposes was recognized. Misinterpretation of radar information had not resulted in any reduction of the number of serious collisions at sea. History. International Conference on Safety of Life at Sea in 1960 revised the international regulation for preventing collision at sea, adding rules to take account of the use of radar and recommendation on the use of radar information as an aid to avoid collision at sea. International Conference on Safety of Life at Sea in 1974 adopted provision to the SOLAS Convention, making a radar a mandatory carriage requirement for merchant ships in phased programming starting in 1980, which finally completed in 2002. All merchant ships of 300 gross tonnage and over now shall carry a radar, and as many as two. IMO adopted performance standard for marine radars, which are used in connection integration with other navigational equipment required to carry on board ships, such as an automated target tracking aid, ARPA, AIS, IGDIS, GNSS, and others. Non-solar ship. Many small craft or millions also carry radars voluntarily as manufacturers have produced cost-effective design for their needs.
The shipmaster's point of view. The radar remains and will remain the primary system for collision avoidance, and radar is very important tool for navigation. So as we all know that radar is very important in our ship in case of emergency, in situation or in fog situation. Why is radar such a valuable tool? The master and watchkeepers have confidence in information radar provides because first, its operation is ship-based. It's not reliant on third-party resources. It has a proven track record. Radar is useful with SARTs when engaged in search and rescue. So, in our radar, we can detect the SART or the search and rescue transponder in case of an emergency on board ship. So in short, in its display, radar offers the watchkeepers the basic reality of all targets relative to ship. It therefore aids the watchkeepers and helps in decision making for both navigation and collision avoidance. So in collision avoidance, early action is required to avoid a close quarter situation. Therefore, early identification of closing targets is essential. Therefore, there is what we call the CPA or the closest point of array, where you will maintain a 2 nautical mile wide in the center of your ship. And for watchkeeping officers need to be competent in the use of radar and are trained in its use and the application of the ARPA. Some of the IMO requirements: maximum emergency stopping distance from full speed of the ship should not be more than 15 ship's length. Emergency turn radius of the ship should not be more than 2.5 ship's length. The ship parameter, so speed is up to 25 knots. The length is the largest container ship, 335 meters, Cape-size bulker, 300 meters, and the Panamax is at 220 to 230 meters. The ship parameter, emergency stopping distance, 3.3 km or to 5 km is 1.8 nautical mile to 2.7 nautical mile. Emergency turning radius is 550 to 840 meters or 0.3 nautical miles or 0.45 nautical miles. In the displacement of weights, there is a 100,000 to 250,000 tons. In the practical requirements, to start plotting targets and determining their course and speed when the target is between 8 and 10 nautical miles off. Radar gives accurate information on distance from charted features and assists in maintaining the ship's course. Radar will normally show a 60-meter high and mass at a range of 20 miles. This is considered by seafarers as a minimum requirement.
RIS MEC 19279. Target description, and then target description and 3 shorelines, annex, SOLAS ships, and 5,000 gross tonnage, SOLAS ship 500 gross tonnage, small vessel with radar reflector meeting IMO performance standards, navigation buoy with corner reflector, typical navigation buoy, small vessel of length 10 m with no radar reflector. And then target features: height above sea level in meters, rising to 60, rising to 6, rising to 3, 10, 5.0, 4.0, 3.5, 3.5, 2.0. Annex, detection range in NM, X-band NM, 28, 6, 11, 8, 5.0, 4.9, 4.6, 3.4, S-band NM, 28, 6, 11, 8, 3.7, 3.6, 3.0, 3.0. Discrimination of targets from a watchkeeper's perspective. To be able to distinguish a tug from its tow at sea at 12 miles range, approaching a rig on a supply vessel. To clearly identify the standby boat from the rig at 6 miles range. To be able to distinguish the anchor pennant buoys of semi-submersible rig at 3 miles range. RIS MSC 19772. 5.5.1 range. The radar system should be capable of displaying 2-point targets on the same bearing, separated by 40 m in range as to distinct objects. 5.5 5.2 bearing, the radar system should be capable of displaying two-point targets on the same range, separated by 2.5 degrees and bearing as two distinct objects. Navigation. Radar greatly assess navigation during poor visibility. Pilot rely on radar at close range and reduce visibility to pass birds and vehicles.
Five 5.4 minimum range, 5.4.1 without ownership at zero speed, an antenna height of 15 meters above the sea level and in calm condition. The navigational buoy in Table 2 should be detected at a minimum horizontal range of 40 meters from the antenna position and up to the range of 1 nautical miles without changing the setting of control functions other than the range scale selector. Engineering terms. RES ITO are M.1313 power 30 to 70 kilowatts, horizontal beam width 0.75 to 4 degrees, pulse width 0.03 to 1.2 microsec, PRF 4000 to 375 Hz, noise figure 3 to 8 dB. Antenna, pitch 3 degrees, roll 25 degrees, yaw 5 degrees, so vertical beam width 20 to 30 degrees. So this is the picture of X-ray band radar and Sierra band radar.